Okay, so what I was saying is once you get to this point, you would try to simplify. Okay? Now, if you were to break 343 down, it breaks into 7 and 49. 49 splits into 7 and 7. You don't have 4 of anything. So it's going to have to say the fourth root of 343. Okay, so if you can simplify, of course simplify it, but here it won't simplify any further, so we're going to have to leave it like that. Okay? Now, for this next problem, you've got 6 to the 1/2 power times 4 to the 1/3 power. Those are not the same base, so I cannot start making them like denominators and adding them. You can only do that when there's the same base. So what I'm going to do is I'm going to take this outer 2, that outer exponent, this is where we're going to do power to a power. Okay? So I'm taking 6 to the 1/2 power and raising that to the second power. And then multiplying that by 4 to the 1/3 power and raising that to the second power. Okay? So 1/2 to the second power, I'm multiplying that. When you have a power to a power, you multiply your exponent. So 1/2 times 2 is just 1. Then I've got times 4. 1/3 times 2 is going to give me 2/3. Okay? So what I'm going to have to do is get this 4 to the 2/3 into radical form. Okay, so I'm going to have 6 times the cube root of 4 squared. Y'all see that? Okay. Well, 4 squared is 16. So I have 6 times the cube root of 16. Well, I need to simplify that. And I know it can be simplified. So 16 will split into 2 and 8, 2 and 4, 2 and 2. So I have a group of 3 2's with a 2 left over. So 6 times 2 cube root of 2 would be the simpler form. And then I'm going to multiply 6 times 2 to get 12 cube root of 2. So here, I mean, I had to switch that to radical form, obviously, right there. I mean, when you can't do anything else with your rational exponent form, then yes, I did it further in than the second to last step, but you have to do that in order to simplify it all the way down here. Okay? So we're going to kind of look at that the same way here, except I'm going to go ahead and I'm going to make this 1 over 4 to the 5th times 3 to the 5th all to the 1/5. I'm going to go ahead and move that entire thing to the denominator because it's negative. I'm going to go ahead and work on it in the denominator. So I'm going to have the same concept. I'm going to take that 1/5 outer exponent and apply it to the two exponents. So I'm going to have 4. Now 5 to the 1/5 power, I'm multiplying that. 5 times 1/5 is just going to give me 1, right? So it's just going to be 4. And then 3 to the 5th raised to the 1/5, it's the same concept. 1/5 and 5 gives me 1, so I'm just doing 4 times 3. So my final answer would just be 1 over 12. Now could I have distributed here and separated and then put it down? Yes, absolutely. But if I see a negative, I'm going to automatically just move it down before I start working. Okay? Now, the difference between this next example and the other two, this has the same base. They're both 5s. Okay? So my rule tells me if I'm dividing like bases, I'm subtracting my exponents, right? Well, this is understood to be 5 to the first power. So I'm doing 5 and subtracting 1 minus 1/3. So that's going to give me 5 to the 2/3 power. And then I can get that into radical form, so I'm taking the cube root of 5 squared, which is the cube root of 25. I cannot simplify that, so that would be my answer. Y'all good with that? You have questions? Okay. So when you use properties of radicals, it says a radical is in simplified form when there's no radicans have perfect nth powers as a factor other than 1. No radicans contain fractions, and no radicals appear in the denominator of a fraction. So we're going to have to rationalize the denominator here. Okay? When I am multiplying, I am trying to always simplify first, just like I did earlier. I want to simplify, so I have to multiply smaller numbers than multiplying 12 and 18. Okay? But the problem is I'm doing the cube root. So if I were to split 12, I'd have 2 and 6, 2 and 3. Right? I can't do anything with the cube root. Now if it were a square root, I could simplify this. Same thing with 18. I cannot do the cube root of 18 and simplify anything. It's going to be 2 and 9, 3 and 3. So I'm back to the same spot. So in this situation, I can't simplify anything first. I'm going to have to multiply 12 and 18. Okay? But there's going to be times where you can simplify. So always check to do that first. Here, when I multiply, I'm going to have the cube root. 12 times 18 is going to give me 216. Then I'm going to see, is that a perfect cube? So in your calculator, if you don't know it, check it. Okay? You can do your 3, then control rooftop. 216. That gives me a 6. So that's my answer there. Sometimes it's going to be that simple. Sometimes it's not. Okay? I'm going to do the one underneath that, so we're doing multiplying, then dividing. Okay? So I've got the cube root, well, I've got 7 times the cube root of 27, x squared, times 4, cube root of 8x. Here's where I can simplify. The cube root of 27 is 3. So I can do 7 times 3, cube root of x squared. Same thing with the cube root of 8. Cube root of 8 is 2. So I can have 4 times 2, cube root of x. Well, that's just 21 times 4 times 2 is 8. Cube root of, well, x squared and x just gives me x to the 3rd power. So you take 21 times 8, 168. Cube root of x cubed is just x. Y'all follow that? Okay. Now, when you're dividing, you're welcome. When you're dividing, I've got the 4th root of 80 over the 4th root of 5. I'm going to still try to simplify that. I'm going to see, can I do 80 divided by 5? Which you can. It gives you the 4th root of 16. Well, the 4th root of 16 is 2. So I would rather try to simplify the numbers under the radicals before I start rationalizing. Okay? Same thing with this next example. I've got the cube root of 162x to the 5th over the cube root of 3x squared. So I'm going to see, can I do 162 over 3 and x to the 5th over x squared? So 162 divided by 3 is 54. X to the 5th over x squared is x cubed. Alright, well 54, when I go and split that, I've got 2 and 27, 3 and 9, 3 and 3. I'm taking the cube root, so I can take that pair of 3, or that group of 3's, with that 2 left over. I can simplify that, and I can for sure do the cube root of x cubed. Okay, so that's going to simplify to 3x cube root of 2. So it's much easier to simplify first. Now if you can't simplify first, like the next section, you're going to have to rationalize the denominator. Okay? We've done that before with square roots. Okay, now we're going to have roots greater than that. So if I have the 4th root of 2 over the 4th root of 3, I can't simplify 2 over 3. So I'm going to have to rationalize. But what am I actually rationalizing? I'm doing a 4th root. So how many 3's do I really need? I need 4 total for it to pull out a total 3, right? Well, I already have 1. So I really need the 4th root of 3 3's. Now, when you're doing your work, no, you don't have to do this. I'm just showing you what you're really needing, okay? So this 4th root of 3 3's is really the 4th root of what? 27. That's what I am rationalizing by. That's what I'm multiplying by. So you have to look at your index. How many do you need? How many do you have? And go from there. So then I'm going to have the 4th root of 2 times 27 is going to give me 54. All over 3. Y'all follow me there? So I needed a 4th root. I had 1 3. I needed 3 more. That's where I got my 27. So altogether that gives me 4 3's, and that's why I'm able to pull the 3 out. Now, you try to simplify 54, but that's going to be 2 and 27, 3 and 9, 3 and 3. It's not going to give me anything with a group of 4. So this is going to be my final answer. Okay, now the 4th root of 3 over 4, I'm going to split that, the 4th root of 3 over the 4th root of 4. Now, if you're just rushing through your work, you see that you have 1 4, right? So you would need 3 4's. But 4 is really 2 2's, right? So use that concept. I have 2 of my 4 2's. So I can really just multiply by another 2 more 2's. Y'all see that? So be careful with what is in your denominator. If this was any other number, like 7, then yeah, you would need 3 more 7's. But I can break down 4 into 2 and 2. There's my other 2 and 2. So try to look at your numbers and see if you can make it easier on yourself. Now, would it have worked if you did 3 more 4's? Yes. You would just have to simplify more. Okay? But here, I'm telling you, split it into 2's. So now I've got the 4th root of 12 over 2. 4th root of 12 does not simplify. So that's my answer. If you would have done 3 4's here, you would have gotten 64. 64 times 3 would have given you a bigger number. That could have simplified. Then you would have had to simplify the 2 outer numbers. You just have a lot more simplifying to do. Okay? So try to catch it with numbers like that. Like for this next example, I've got the 5th root of 3 over the 5th root of 4x squared. Well, again, the 4 can be 2 and 2. So when I rationalize this, I need how many more 2's? I need a total of 5, right? I have 2, so I need 3 more. 2 to the third is 8. Now I got to pay attention to my x's. I have 2 x's, so I need to rationalize it and multiply by x to the third. Y'all see that? Understand that? Okay. So then I'm going to have the 5th root. 3 times 8 gives me 24 x cubed. And then I would have 2x as my denominator. And that does not simplify. Okay? Now this next example, you've already done problems like this next example. I just threw it in there for review. Okay? So I've already taught you, what would I do here? How would I rationalize this? Yeah, you use your conjugate. 4 plus square root of 3. So this is a situation I've already taught you, so it's fair game on a quiz or a test. I wouldn't have to throw it in notes and worksheets. So then I am multiplying this 5 to the 4 and the square root of 3. I'm distributing that. So I should have 20 plus 5 square root of 3 over 16 minus 3. So 20 plus 5 square root of 3 over 13. Alright, because you have 4 times 4, which will give you your 16, and then square root of 3 times square root of 3 gives you your 3. You would check to see if those 3 numbers could simplify. You've got a prime number in there, so you can't. Y'all good? Okay. Now, when you start getting rational exponents, it starts getting a little bit messier. Okay? So to rationalize the denominator with rational exponents, you're going to multiply by whatever will get you an exponent of 1. So remember that when you're multiplying bases, you add your exponents. Okay? So here I've got x to the negative 5 over 6. Well, that tells me it's 1 over x to the 5 over 6 power. Now, when you're looking at your rational exponents, your denominator is your root, right? Your denominator is telling you how many total you want. I want 6 total. I already have 5. I need 1 more. So I'm going to multiply it by 1 over 6. So you're looking at the denominator. That's your total that you want. You need to get the numerator to that total. I have 5. I need 1 more. So that's going to leave me with x to the 1/6 in the numerator and just x in the denominator. Okay, because 5/6 plus 1/6 would be 6/6, which is 1. Then I'm going to put that numerator in radical form. So it's going to be the 6th root of x over x. When it's something with one term, it's very simple. Okay? So this next example, same thing. I'm putting it 1 over y to the 3/7 power. I need how many total? 7. That's my denominator. I have 3 already. So what do I need to multiply it by? 4/7. So I get y to the 4/7 power over y. Put it in radical form. I've got the 7th root of y to the 4th over y. Okay. When you have this next example, you've got x to the 1/5 plus 1. You've got 1/2, not 1/5. x to the 1/2 plus 1, x to the 1/2 minus 1. This is a binomial in the denominator. When you have a binomial, you've got two terms, this is where you're going to do the conjugate. Just like we just did. That's why I threw that example in there. So I'm going to multiply by x to the 1/2 plus 1. So my numerator, I'm foiling that. X to the 1/2 times x to the 1/2. I add my exponents, 1/2 and 1/2 is just 1. Then I've got x to the 1/2 plus x to the 1/2 plus 1. My denominator, it's my conjugates, so x to the 1/2, x to the 1/2 is just x minus 1 times 1 is 1. Okay? Now, in my numerator, I can clean up those two middle terms. So that leaves me with x plus 2x to the 1/2 plus 1 over x minus 1. Put this middle term in radical form. I have x plus 2 square root of x plus 1 all over x minus 1. Now, if you really wanted to check your answers, you could take any number, store that value for x in your calculator. You have to be very careful when you're typing your original, but you would type your original, then you would type this answer and make sure the two numbers, whatever those numbers are the same. Okay, so if you're curious on how to do that and you want to do that, I can show you. You just have to be very tedious when you're typing it in. Okay? But not everyone's going to do that, so I'm not going to take the time to do that right now. Okay? This next one. X to the 7/3 plus x to the 10/3 over x to the 1/3. I am not adding 7/3 and 10/3 because I am not multiplying those bases. What I'm going to do is just rationalize because I can't combine these two. So I'm going to rationalize. I have x to the 1/3, so I'm going to multiply that by x to the 2/3. What's going to happen is I'm going to take that x to the 2/3 and I'm going to distribute it. Now I am multiplying like bases, so I'm adding exponents. Okay? So my denominator I know is x. My numerator, I'm taking x to the 7/3 times x to the 2/3. So I'm taking 7 plus 2 to give me 9/3, which is just x cubed. Then I'm doing the same thing. X to the 10/3 times x to the 2/3. 10 plus 2 is 12. Divided by 3 just gives me x to the 4. Now, I've got x cubed, x to the 4th, and x. I need to take out a GCF in my numerator. I need to clean it up as much as I can. Okay? I can take out x cubed as my GCF. And that would leave me with 1 plus x over x. I can simplify now x to the 3rd over x, and that's going to give me x squared times 1 plus x. It doesn't matter. I'm not going to be picky about that. I just leave it in the order that it started with. Do y'all have any questions on that?